This is a simulation website that lets me randomly select a sample from a population of 18,000 people. In this box right here, we can see the sleep time of each of the 18,000 people in the population. In this column, we see the ID number of each person in the population. And over here, we see each person's sleep time. So it looks like person 1 sleeps 6.5 hours per night, person 2 sleeps 6 hours per night, and person 3 also sleeps 6 hours per night. And this goes all the way down to 18,000 because there's 18,000 people in the population. Down here, we can see that the sleep times of the 18,000 people follow a roughly normal distribution. The mean, or the average, sleep time of the population is 8, or to be exact, it's 8.001. So if we added all 18,000 sleep times and divided the total by 18,000, it would come out to 8.001. We can see that that population mean of 8 is right at the center of the population, right here. Because when a population follows a normal distribution, the mean is at the center. Actually, the mean, median, and mode are all at the center of the distribution. So over here, we can see the people in the population who were below average and who were getting less than 8 hours of sleep per night. And down here, we can see the really sleep-deprived people who were getting less than 4 hours per night. Up here, we can see the people in the population who were above average, who were getting more than 8 hours of sleep per night. And down here, we see the people who were getting a lot of sleep. For example, these people are getting 12 hours of sleep up here. So now that we understand what this screen is showing, we'll actually randomly select a sample from this population. The first thing I need to do is click right here where it says Show Sampling Options. And I can pick a sample size. I can type whatever number I want in here, but I'll use a sample size of 10. And so when I click on Draw Samples, it's going to give me one sample of 10 people. It's going to randomly draw 10 people from this population. And then it's going to collect data from those 10 people, and it's going to show their 10 sleep times inside this box right here. So here's my sample of 10 people. These are their ID numbers, and these are their sleep times. So this is just randomly selected 10 people from the 18,000 people over here. We can see that my sample of 10 people has a mean sleep time of 8.025. So if we added their 10 sleep times and divided the total by 10, we would get 8.025. This is just showing that the sample mean is at the center of the sample. The sample mean is at the center of the 10 people in the sample, which makes sense. Over here, we can see the sample mean of 8.025 plotted as a single block above this number line. So this is just one block in the sampling distribution of all possible samples of 10 people that could be selected from this population. Let's randomly select another sample of 10 people. So we're repeating our study. So now it's randomly selected a different group of 10 people from this population, and it's recorded their sleep times. My new sample has a mean of 7.7. So if you added these 10 sleep times and divided the total by 10, it would come out to 7.7. So my new sample is a little bit more sleep deprived than my first sample because my second sample has a lower sample mean. And one thing I haven't shown you yet is that if you look over here, it actually highlights the 10 people in the sample inside of the population that they came from. So this person who's sleeping 9 hours is probably right here somewhere. It's probably this person. This person who's getting 6.25 hours, that person is probably that person right there. Now let's select a different sample of 10 people and calculate the new sample mean. This time, the sample mean came out to 8.425. So my third group of 10 people has a mean of 8.425, and it plotted that sample mean right there. So each time it takes a new sample from the population and calculates the sample mean, it plots that new sample mean on this graph right here. Each sample mean that's calculated is shown as a block. So this was the mean of sample 1, this was the mean of sample 2, and this was the mean of sample 3. Also, when you go and click on another sample, it actually shows you the 10 people that were in that sample. So these were the 10 people from sample 1, these were the 10 people in sample 2, and these were the 10 people in sample 3. And if you click on this sample mean down here, you can see that these 10 people are a little bit lower. They're getting a little bit less sleep. And you can see that these 10 people over here are kind of getting more sleep, especially because of this person up here. That's why these 10 people had the lower mean, and these 10 people had the higher mean. Now I can keep drawing more and more samples of 10 people, and it'll keep calculating the mean of each sample. And each new sample mean will be plotted as a new block on the number line. And it tells me how many samples I've selected so far. So far I've calculated the means of 62 different samples. So these are the 62 sample means that I've calculated. And each sample mean is the mean of a different group of 10 people who come from this population right here. This group of 10 people has a pretty high sample mean. This sample of 10 people has a mean of 9.1. And if we look at the 10 people over here, we can kind of see why their sample mean is so high. It's mostly because of these 3 extreme people who are bringing up the mean of the sample. And the most important point I wanted to make here is that if we actually calculated the mean of every possible sample of 10 people that could be chosen in this population and plotted all of those sample means on this graph, those sample means would follow a normal distribution right here. This shape would be normal. The reason why is because if the population is normal, the sampling distribution is always normal. And I don't think this will let me calculate the mean of every possible sample because there's too many possible combinations. But if I calculate the means of 10,000 different samples and I plot those 10,000 sample means in here, I'll end up seeing a shape that's pretty close to the shape of the entire sampling distribution. So it's gonna draw 10,000 samples one at a time. Each sample will have 10 people, and it's going to calculate the mean of each sample. So it's going to plot 10,000 different sample means down here. So we can see that it is roughly normal. And if I click inside of here, I can actually look at the 10 people inside each of the samples. So let's look at this number 8 right here. Each building block that's stacked above 8 right here is just the mean is the mean of a different group of 10 people, and it just happens to be that all of those different samples all have a mean of 8. So here is one group of people with a mean of 8. Here's a different group of people with a mean of 8, and here's another group of people with a mean of 8. They're just all stacked above each other. Down here, we see all of the possible samples that have a mean of 7. And up here, we see all of the possible samples that have a mean of 9. But it's important for us to realize that every sample mean that's plotted in here is the mean of a different combination of 10 people. Now, what if I wasn't using a sample size of 10? What if I was using a sample size of 30? Well, if I click on Draw Samples, it'll let me draw samples of 30. So what I'm doing right now is each time I click on this icon right here, it draws 30 people from this population randomly, and it calculates the mean of the sample. And so far I've done it 4 times. So this is the mean of one group of 30 people. This is the mean of a different group of 30. This is the mean of a different group of 30. And here's the mean of one other group of 30. Now, the sampling distribution for the sample size of 30 includes the means of all possible samples of 30 that could be chosen from this population. If I was able to actually calculate the means of all possible samples of 30 that could be chosen from the population and plot all of those sample means on here, that distribution would be the sampling distribution for the sample size of 30. And I probably can't do that because there's too many possible samples, but just like last time, I'll take 10,000 samples, and I think that'll give us a shape that's pretty close to the sampling distribution. So what this is going to do is it's going to select 10,000 samples of 30 people one at a time. So it's going to take 30, it's going to take 30 again, and it's going to take 30 again, over and over. And each time it does that, it's going to calculate the mean of the sample. So it's going to randomly select 30, calculate the sample mean, randomly select 30 more, calculate the sample mean, and it's going to do that 10,000 times. And each time it does that, it's going to plot the new sample mean on here. So there's going to be 10,000 sample means on here. And that's going to be, the shape is going to be pretty close to the shape of the sampling distribution for the sample size of 30. It might just take it a second to do this because it has to do it 10,000 times. Oh, there it is. So it's plotted the 10,000 sample means on here. So this is just showing 10,000 different sample means. And each of those sample means is the mean of a different group of 30 people that was selected from this population. So down here we have samples with really low sample means. And up here we have samples with really high sample means. So down here would be a group of 30 people who's more sleep deprived. So these 30 people have a low average. Um, here we have a group of 30 people that's more well rested, and so this sample has a high average. And in here we have all of the groups of 30 people that have more medium averages close to the population mean. So these samples are less accurate. They don't represent the population as well, and these samples are also less accurate. And the more accurate samples are in the middle, because in the middle we have the samples that have sample means closer to the population mean. But the most important point I wanted to make here is that the shape of these sample means is normal, just like the shape of the population. So far we've looked at two different sampling distributions. We looked at the sampling distribution for the sample size of 10, and now we've looked at the sampling distribution for the sample size of 30. The sampling distribution for the sample size of 10 was just the means of all possible samples of 10 people, and the sampling distribution for the sample size of 30 is just the means of all possible samples of 30 people. And we've seen that both sampling distributions have a normal shape. So far we've demonstrated the first point of the central limit theorem, which is that if the population is normal, if the individuals in the population follow a normal curve, then the sampling distribution is always normal, regardless of what sample size you're dealing with. It doesn't matter if the sample size is 10, 30, or any other number. Now at this point I want to demonstrate the other point of the central limit theorem, which talks about what happens when the population is skewed. So right here, I can change the population to a skewed population. So here we have a population that's positively skewed. Most of the people in the population are at the low end, so we have a lot more sleep-deprived people, and you see fewer and fewer people when you go up to these higher sleep times. So I said the population is positively skewed. And let's try to randomly select a sample of 10 people from this population and calculate the mean of the sample. So it's going to draw 10 people and calculate the mean of the sample. The sample mean came out to 8.675. That's the mean of these 10 selected people, and it plotted the sample mean right here. Now let's take 10 other people and calculate the mean of our new sample. This sample mean came out to 7.6. So this is the mean of sample 1, this is the mean of sample 2. And if we do this over and over again, what you'll start to notice is that since the population is positively skewed, our 10 people are typically coming from the low end of the population down here. That's happening simply because there's a lot of people to draw from down here and not as many people to draw from down here. So since our 10 people are typically coming from the low end of the population, our sample mean is typically coming out to a low number down here. So if we keep doing this over and over again, the sample means are going to pile up toward the low end. The sample means are going to keep piling up at the low end, and they're not going to pile up as much at the high end, because we're going to be getting a lot more sleep-deprived samples and a lot fewer well-rested samples. So the sampling distribution right here is going to end up looking like the population. It's going to be positively skewed because, like I said, the sample means will pile up here at this end more quickly than they do over at this end. Let's take a look at that. And we're not going to really see the shape until we have lots of samples in here. So far we have about 94 sample means in our sampling distribution. Now I'll try to take 10,000 just like I did before. So there's going to be 10,000 sample means in the distribution. It just takes it a second because it's calculating the means of so many samples. So we can see that this sampling distribution is positively skewed, just like the population. It's positively skewed just like the individuals in the population. It's not as skewed as the population is, but it's still somewhat positively skewed. So this shape does kind of look similar to this shape. And this is just demonstrating this part of the central limit theorem, because I said that if the population is skewed and you take a small sample from the population, like a sample size of 10, then the sampling distribution is skewed just like the population. And I also told you that if you take a larger sample, like 30, then the sampling distribution will be roughly normal, even though the samples are coming from a skewed population. So let's do that. This is my first sample of 30 that's been selected. So it took 30 people from this population, and it calculated the mean of the sample. It's not showing up yet, but it should show up soon. Oh, I think I clicked on 10,000. I wanted to do them one at a time, but I accidentally clicked on 10,000. Okay, so it already plotted 10,000 different sample means, and each sample mean is just the mean of a certain group of 30 people. And we can see that the sampling distribution has a roughly normal shape, even though each of the samples came from this skewed population. I wanted to talk a little bit about why it ended up being a normal shape instead of the skewed shape that we saw before. First, I'll need for this to refresh, I think.